Welcome to Outbreak Brief, the podcast that takes you inside the world's most dangerous infections.
Yeah, we have a really fascinating one today.
We really do. Today's deep dive takes us on the trail of a completely shape-shifting, just ubiquitous threat. We are tracking a pathogen that is honestly just as likely to cause a mild winter sniffle in a toddler as it is to trigger massive, silent, and totally deadly outbreaks in military barracks.
Right. And perhaps most unsettling of all, this invisible enemy is entirely capable of hiding out, just completely dormant, deep inside your own human tissue for years.
It's wild. It truly is a master of survival, and because it's been locked in this evolutionary arms race with us for a very long time, it has developed some terrifying biological mechanics to ensure it always finds a host.
It really has.
So let's set the stakes here by picturing a scene. I want you to imagine a military training camp right in the dead of winter. The air is bitterly cold. You have hundreds of recruits packed into these incredibly close quarters. They are super stressed. Their immune systems are completely exhausted from all the physical training, and they are sharing lockers, weapons, and just breathing the exact same recycled air.
The perfect storm, really.
Exactly. And suddenly, a wave of severe, acute respiratory disease sweeps through the barracks. Men and women are just dropping with high fevers, hacking coughs, and pneumonia. Now, if you're listening to this, your first thought is probably the flu.
Right. Or maybe COVID.
Yeah, COVID, RSV, something like that. But this isn't any of those. This is a virus that can survive for hours, not just hanging in the air, but sitting right on the freezing cold steel of a gun barrel.
Yeah.
Or woven into the fabric of a shared pillow.
Yeah, that environmental resilience is what makes it an absolute nightmare in any kind of congregate setting. I mean, it doesn't need a host right away. It just waits.
It just sits there.
It just sits there. And while an infection might only cause, a miserable few days for a healthy 19-year-old recruit, the stakes are exponentially higher for others.
Right. For the immunocompromised, so patients who have just had an organ transplant or who are battling cancer, this virus is completely devastating. In those vulnerable populations, the mortality rate can actually skyrocket up to 70%.
70%?
Yeah.
I mean, that is a staggering fatality rate for something most of the public just brushes off as a common cold.
It really is.
And to make matters worse, this pathogen basically laughs at the common household cleaning methods we all rely on to keep our families safe. So, let's put a face to this villain. What exactly are we dealing with here?
Well, we are dealing with adenovirus.
Right.
And biologically speaking, it is a double-stranded DNA virus.
Okay.
And it's incredibly small. We're talking measuring only about 70 to 90 nanometers across.
Which is microscopic even by viral standards, right?
Absolutely.
But looking at the imaging in our research files, what it lacks in size, it completely makes up for in structural armor because it features what's called an icosahedral capsid.
Yes, the capsid. Honestly, it looks exactly like a 20-sided die from a tabletop role-playing game, like Dungeons & Dragons.
That is actually a brilliant way to picture it. It is a perfect geometric transport vehicle. And inside that 20-sided die, the virus's DNA is tightly wound around this histone-like core protein. It's called protein 7.
Protein 7, okay.
And that protein acts like a shock absorber, basically protecting the genetic payload during the chaotic phase of the acute infection.
But here's what I don't really understand. If I cough on a locker handle, I leave a virus behind, sure. But I always thought viruses was super fragile outside the body. Doesn't the fat layer around most viruses just dry out and burst after a few minutes in the air?
Ah, so you're thinking of enveloped viruses,
Okay.
like influenza or SARS-CoV-2. Those viruses are wrapped in a lipid envelope, which is essentially a fragile bubble of fat.
Right.
If that fat bubble dries out, the virus dies. It falls apart. But adenovirus is a non-enveloped virus. It does not have that fragile fat layer, that 20-sided die we talked about. It's made of solid, hard shell protein.
Oh, wow. So it's not a fat bubble. It's like an armored Kevlar tank.
Exactly like a tank.
Well, that perfectly explains how it survives on cold steel for hours.
Yeah.
But if it's this heavily armored and structurally complex, how many different versions of this tank are actually out there?
Well, the sheer diversity of the Adenoviridae family is kind of staggering. There are more than 100 serologically different types.
100?
Yeah. And they are broadly divided into the aviadenoviruses, which infect birds, and the mastadenoviruses, which infect mammals.
Okay, so birds and mammals.
Right. And out of all of those variations, there are exactly 49 types that possess the specific molecular keys designed to breach human cells.
49 distinct versions,
Yeah.
all highly adapted to us.
Yeah.
Which makes me wonder about the timeline here. Like, when did we actually actually realize this thing was circulating among us?
So the official discovery brings us back to 1953.
Okay.
Researchers Wallace Rowe, Robert Hubner, and their colleagues were studying human adenoids, which is the lymphatic tissue located high up in the back of your throat.
Right, like when kids get their tonsils and adenoids out.
Exactly the same tissue. So they had these adenoid tissues sitting in a laboratory culture, and they noticed something completely bizarre. The cells were spontaneously degenerating.
Now, the research paper used the term cytopathogenic agent. Can you break that down for us? What does that actually mean?
Sure. Let's look at the root words. Cyto means cell, and pathogenic means causing disease.
Okay.
So they were observing an invisible agent that was literally causing the human throat tissue in their petri dishes to dissolve, just fall apart from the inside out.
That is horrifying.
It is. And because they first isolated it in that adenoid tissue, they named it adenovirus.
Makes sense. And since 1953, the history of its outbreaks reads like a heat map of human vulnerability. It strikes wherever people just can't keep their distance from each other.
Always in crowded places.
Yeah. Like in 2005, an outbreak of adenovirus type 3 swept through a pediatric long-term care facility in Illinois. And then in 2017, a really tragic outbreak of type 7 hit a substance abuse rehabilitation center in New Jersey. That one actually resulted in several fatalities. We see it sweeping through college dorms and daycares all the time. But wait, if this thing was dissolving throat tissue in a lab, how is it physically jumping from a sick person to a healthy person in, say, a crowded rehab center?
Well, it employs a relentless, multi-front attack strategy. The transmission routes are incredibly diverse.
Okay, walk us through them.
First, it uses standard respiratory transmission, so coughing and sneezing release aerosolized droplets into the air.
Like a normal cold.
Exactly. But it can also spread through direct inoculation to the conjunctiva.
The eyes.
Right. If the virus gets onto your hands and you rub your eyes, you're infected. And then there's the fecal-oral route, which is notoriously common in daycares during diaper changes.
And this brings us back to that Kevlar armor. The medical term mentioned in the sources is fomite transmission. And a fomite is just an inanimate object that carries an infection.
Yeah.
You touched on this earlier, but I really need to make sure the listener grasps how wild the survival time of adenovirus is. We are talking about unwashed linens, pillows, locker room benches. If I touch a doorknob that someone sneezed on 6 hours ago, I can still catch it.
You absolutely can, provided you then touch your mouth, nose, or eyes. The protein shell keeps the viral DNA perfectly intact.
That is crazy.
It really is. And what makes stopping the spread so difficult is the timeline of the infection. The incubation period, so the silent window from when you are exposed to when you actually first feel sick, that can last anywhere from 2 to 14 days.
2 weeks. So for up to 2 weeks, you are going to work, you're hitting the gym, you're playing with your kids, completely unaware that the tank has breached your system.
Completely unaware.
And even after you get sick and recover, the threat isn't over. The sources mention silent shedding. How does a healthy person keep spreading a virus?
Oh, this is a masterstroke of viral survival. A person can actively release infectious viral particles from their body, usually down the fecal-oral route through their stool, for weeks or even months after they have completely recovered from the clinical symptoms.
Months later.
Months. And this is especially true for people with weakened immune systems. I mean, they have no symptoms, they feel entirely fine, but their gut is still manufacturing the virus. They become a walking, silent vector.
And it spreads in water, too.
Yes, it does.
The CDC files explicitly note it can spread in community swimming pools or lakes that just lack adequate chlorine. You could literally swim into an infection.
You really could.
So if you're a parent listening to this and you're wondering why a mild daycare sniffle suddenly wiped out your entire house, well, this is why. Which leads us to the targets. Who is most at risk here?
Well, as we just mentioned, children are incredibly susceptible. Their immune systems are still developing. They obviously haven't encountered these 49 variants yet. And frankly, toddlers aren't exactly known for their rigorous hand hygiene.
Very true.
So the highest risk groups are infants and toddlers aged 6 months to 2 years, and then kids aged 5 to 9.
But adults are still catching it. I mean,
Yeah.
we talked about the military recruits and college students.
Right, they were catching it because of their sheer physical proximity to each other. But the truly dire cases, the ones that force infectious disease doctors to scramble, involve patients with pre-existing conditions.
Like what kind of conditions?
If someone has an underlying cardiac or respiratory disease, a severe adenovirus infection can easily push their struggling system over the edge. And for the immunocompromised, so patients undergoing heavy chemotherapy or those who have had bone marrow or organ transplants, they literally lack the white blood cells necessary to fight back.
They have no defense.
None. Without an immune system to scorch the earth, the virus just replicates unchecked and disseminates to every organ in the body. That is where we see mortality reach 70%.
Let's talk about what the virus actually does once it gets inside, because adenovirus has this fascinating, almost mechanical quirk that dictates the disease. It's called the rule of entry, meaning the exact spot where the virus enters your body dictates the type of illness you're going to get.
Yeah, think about those 49 different human variants we discussed earlier. They each have slightly different protein spikes protruding from that 20-sided dye.
Okay.
Those spikes act like highly specialized keys. If you inhale aerosolized droplets, the keys on those specific viral variants unlock the cells in your respiratory tract. That manifests as croup in children, acute bronchitis, which is a brutal chest cold pneumonia, high fever, and pharyngitis.
Okay, so that's the lungs. What if it gets in your eyes? Say you touch that contaminated locker handle and rub your eye.
Then you are introducing variants like types 8, 19, or 37, and those possess the keys for eye tissue.
And what does that do?
You are dealing with epidemic keratoconjunctivitis, or EKC.
That sounds intense.
It is. This is a severe, highly contagious inflammation of both the cornea and the conjunctiva. It is essentially an extreme, incredibly painful form of pink eye. It can sweep through an entire ophthalmology clinic in days if strict disinfection protocols aren't followed.
Wow. And if you swallow it, say from that contaminated community pool we talked about.
The enteric variants, specifically types 40 and 41, bypass the lungs entirely because their keys only fit the locks in the gastrointestinal tract. That results in acute gastroenteritis, so severe diarrhea, vomiting, and intense stomach cramps.
And the sources mention even rarer manifestations too, like neurologic diseases affecting the brain and spinal cord, or hemorrhagic cystitis, which is gross, bloody urine.
Yeah, it really can go anywhere.
It is a full-spectrum nightmare. But I really want to talk about how it does this damage, because it's brutal. The medical term used in the literature is a lytic infection.
Right, lytic.
Can you translate the mechanics of that for us? What is actually happening at a cellular level?
It's not just sneaking into your cell. It's a completely hostile takeover.
Oh.
The virus docks onto a human epithelial cell, injects its DNA, and completely overrides the cell's internal programming. Your cell basically stops doing its normal job and is forced to become a virus factory. It just manufactures thousands of viral clones.
And then what?
Once the replication cycle is complete, the virus triggers cytolysis.
Meaning it literally blows the cell up.
Exactly. It destroys the cell membrane, bursting outward to infect all the neighboring cells. And when your body detects all of these exploding cells, your immune system panics.
I would imagine so.
It releases a massive flood of inflammatory proteins called cytokines, and that massive cytokine production is actually what causes most of the severe symptoms you feel. The raging fever, the swelling, the pain. Your own body is basically scorching the earth to stop the viral spread.
Man, with the body under a multi-front lytic attack, cells just bursting everywhere, we must have some sort of heavy-duty medicine to stop the factory, right? An antiviral we can just prescribe.
Well, the hard truth is our antiviral arsenal here is shockingly bare. There are absolutely no FDA-approved specific antiviral medicines for adenovirus.
Nothing. Not a single dedicated drug.
None. For the vast majority of people, the frontline defense is purely supportive care.
So treating the symptoms.
Right. Hydration, non-steroidal anti-inflammatory drugs to manage the fever, and strict bed rest. You essentially just have to wait it out and endure the lytic cycle while your immune system builds custom antibodies.
But wait, you can't just tell a transplant patient facing a 70% mortality rate to drink water and rest. What do doctors do when the system is collapsing?
In those critical cases, infectious disease specialists will turn to last resort antivirals like ganciclovir or vidarabine. But we really have to be transparent about the limitations here.
Because they aren't approved for this.
Right. These drugs are not specifically approved for adenovirus. They work by interfering with DNA replication across the board. The problem is, stopping DNA replication is highly toxic to the patient's own human cells, too.
Oh, I see.
Yeah, the severe adverse effects of these drugs can sometimes be as dangerous to an already weakened patient as the virus itself. It becomes this terrifying balancing act for the medical team.
Wow. So if treatment is basically just waiting it out or risking incredibly toxic side effects, surely modern science has built a vaccine. I mean, we have vaccines for the flu, for COVID, for measles. And looking through the CDC files, I actually found a wildly intriguing detail.
The military vaccine.
Yes, there is a vaccine, but if I walk into my local pharmacy today, they will refuse to give it to me. The general public is not allowed to have it.
Yeah, the FDA has strictly approved this vaccine only for U.S. military personnel, specifically those aged 17 to 50 who are entering basic training. It's an oral enteric-coated vaccine that targets adenovirus types 4 and 7.
Which are the main culprits behind those massive barracks outbreaks we talked about.
Exactly.
But why the exclusivity? If we have a shield, why is it locked behind military clearance?
It really comes down to the mechanics of the vaccine itself. It contains a live, albeit weakened, version of the virus. Because it is taken orally and replicates in the gut, the recipient actually actively sheds the live virus in their stool.
Oh.
Yeah. So in a tightly controlled environment like a military basic training camp, where everyone is young, healthy, and receiving the vaccine simultaneously, the shedding is contained and manageable.
Ah, I see. But if you gave that live vaccine to the general public?
Right. If a civilian gets it, goes home, and sheds the live virus into the municipal wastewater or, a shared household bathroom, they could accidentally infect an immunocompromised family member.
We would literally be sparking the very outbreaks we are trying to prevent.
Exactly. Plus, its safety has never been rigorously studied in children or pregnant women.
So we are using a controlled burn to prevent a forest fire, but we just can't let that controlled burn anywhere near the civilian population.
That's a good way to put it.
So without a public vaccine, humanity's only defense is physical infection control. Which brings us right back to that Kevlar armor, because adenoviruses basically laugh at many normal disinfectants. If standard household cleaners don't work, what actually does?
You really have to bring in the heavy artillery. The CDC recommends 95% ethanol solutions. For environmental surfaces in hospitals or daycares, you must use EPA-registered disinfectants, specifically those on List G.
List G, okay.
Yeah, these are the same heavy-duty, hospital-grade bleaches used to kill norovirus.
Now, let's talk about hand hygiene, because there is a very specific rule everyone listening needs to know right now. Those little alcohol-based hand sanitizer pumps that we all carry in our pockets, they're practically useless against this.
Completely useless. And if we look back at the biology, it makes perfect sense.
Because of the fat layer.
Exactly. Alcohol hand sanitizers work by dissolving the outer lipid envelope, the fat layer of viruses like COVID or the flu. Once the fat melts, the virus falls apart. But remember, adenovirus doesn't have a fat layer.
It has a solid protein shell.
Right. Alcohol just doesn't break down that protein efficiently. You absolutely must use good old-fashioned soap and water combined with the mechanical friction of scrubbing your hands to physically wash the viral particles down the drain.
Friction is the key. Okay, so no public vaccine, an armored shell that ignores hand sanitizer, and it survives on surfaces for hours. What does the battlefield look like globally right now? Are public health officials tracking this?
Well, we are basically living with an invisible endemic. Adenovirus circulates throughout the entire year, dipping and peaking, mostly in winter and early spring, but it never truly goes away.
Right.
Yet the most chilling reality of our current situation is a massive surveillance blind spot.
Yeah, the CDC documents note that adenovirus infections are not nationally notifiable in the United States.
Meaning clinicians are not mandated to test for it, and if a doctor does run a specialized panel and finds it, they are under absolutely no obligation to report that case to public health authorities.
We are flying completely blind.
We are.
Massive outbreaks are likely sweeping through daycares and college dorms right now, and they are just being brushed off as a quote-unquote nasty bug. We only really map the severe outbreaks when people end up hospitalized or when local health departments are forced to launch an investigation.
Which is exactly why researchers are urgently looking toward the future. We need a way to neutralize this threat safely for the general public, and the biggest hope lies in recombinant DNA technology.
Okay, explain that like I'm 5. If we can't use the live virus because it sheds, how does recombinant technology solve the problem?
Okay, so instead of sending the entire armored tank into the human body to train the immune system, scientists are using recombinant tech to essentially snap off just one piece of the armor.
Oh, okay.
Specifically the purified fiber or hexin proteins. By injecting just that harmless piece of protein with absolutely no viral DNA payload inside, they can safely teach the immune system what the enemy looks like.
That's brilliant.
It triggers high levels of neutralizing antibodies without any risk of the virus replicating or shedding.
That is incredibly promising.
Yeah.
But as we wrap up, I have to bring up the most unsettling finding in the Stat Pearl's medical research. It sounds like pure science fiction.
Oh, the oncogenic finding.
Yes. The research explicitly notes that adenovirus is oncogenic in rodents, meaning it causes cancer in rats. How is a cold virus causing tumors?
Right. So when adenovirus infects rodent cells, it produces these potent proteins called E1A proteins. Once inside the nucleus of the cell, these proteins alter cellular transcription.
What does that do?
They essentially hack the cell's programming, deregulating a process called apoptosis. Apoptosis is a cell's natural suicide switch. It's the cell's ability to safely die when it detects that its own DNA is damaged.
Okay.
By destroying that suicide switch and forcing rapid, unchecked replication, the virus causes malignant oncogenic transformation. It literally forms tumors.
Now, to be absolutely clear to everyone listening, the sources explicitly state that this oncogenic transformation has not been observed in humans. We are not saying adenovirus causes human cancer.
No, definitely not.
The research shows it does something else in humans that is equally sinister.
It does. It establishes chronic, latent infections.
Yeah.
Right. While the exact mechanism remains a medical mystery, we know the virus has the terrifying ability to hide silently in our renal parenchyma, which is the functional tissue of our kidneys, as well as deep in our lymphoid tissues, like the tonsils.
It just sits there for years.
Years.
It isn't causing disease. It isn't replicating enough to trigger an immune alarm. It's just waiting.
It is waiting for the immune system to dip. The moment a person undergoes extreme physical stress, contracts a secondary severe infection, or requires immunosuppressive therapy later in life, that dormant virus can reactivate and strike from the inside.
It is the ultimate sleeper agent. You could survive a miserable chest cold when you're 7 years old, and that exact same Kevlar-armored invader could be resting inside your kidney tissue decades later.
It's a chilling testament to how perfectly adapted this pathogen is to the human host. It doesn't just infect us, it colonizes us.
It becomes a quiet, uninvited passenger in our own biology. So, as you go about your day-to-day and as you wash your hands with soap and water, remember, take a moment to ponder the microscopic world. Consider the distinct possibility that you might currently be carrying a dormant icosahedral invader deep within your own lymph nodes, just biding its time. Stay informed, stay prepared. This has been Outbreak Brief.